Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
I love how focused your value proposition is. I think you state it very clearly, right? If you can get 10 minutes of somebody's time on the screen, you have to make that time count, and then your job is to make sure that that's 10 minutes well spent. Let's transition to the second part of the podcast and look at how you make sure that those 10 minutes are well spent, that you're presenting the right information in the right context. And we can go a little bit technical here. I probably won't understand much of what you're talking about, but it's a good lesson for me and everybody else listening to go a little bit out of our depth and do our best, let's say, to understand what makes your system work. Maybe we can start though a little bit higher level. What are the products? I think you have two products. Am I right in the market right now?
Right. So we have really so we have a technology, an underlying technology, and then our first kind of flagship product that we've built on it. So I'll talk a little bit about the technology first, and then our product. So when I started the company, I was really focused on figuring out, where within, say, the chain of operation in an industrial company is the best place to insert a piece of software that's fundamentally designed to take in these heterogeneous streams of data, distill them down into this idea of a stability score, this index of operation, and then produce these high value alerts. And so if you think about kind of these different sets of constituents or different layers in an organization, the kind of core layer is that operational technology side, or what is often referred to as kind of the edge of the operation. That's inside the facility, right next to where those data and those bits are being produced. But those same bits end up flying out to kind of a secondary layer, which we kind of think of as the control room, right? So they're not the folks who are actually walking around the plant floor, but again, is those managers, so those people who are not having to do the minute-to-minute, hour-to-hour analysis, but maybe doing the day-to-day, week-to-week analysis. And so it's the same data, but they have a slightly different context for how they're using it. The final layer, the sort of exterior layer of that, is kind of at the corporate level or at the headquarters level. And so these are the folks who are not at all on the operations side, but are looking at lots and lots of data, potentially across many different production facilities, and having, again, a sort of different context and a different set of questions. And so with that kind of general map in our heads, what I wanted to do is I said, well, the place that we think we can have the most immediate impact is if we go right to the source of that data and go right into the facility and start building our operation. So the first piece of technology that we built was, how do we, if we want to do kind of distributed, real-time, unsupervised learning from these streams of data, from these assets, how would we actually tile that together so that we could build this kind of top-level view? And so we began to build what is now a kind of core library, core technology, which we call Floodplain. And Floodplain, without going too deep into what the technology is really just a way of doing kind of generalized, unsupervised learning from these streams and actually distributing that software across multiple nodes of compute within any given scenario. And so the idea is, if you wanted to stick a piece of software out, let's say on a wind turbine sitting in the Midwest, you could use Floodplain to put that on any one of those wind turbines, and it would learn a stability score for that one wind turbine, and then that could be transmitted up, and we could have an entire stability of all the wind turbines at once. Or likewise, for for a single asset inside a manufacturing facility, we can do it for all the assets and build this top-down view. And in the early days of the company, we had some really interesting opportunities to try this. Probably the one that I'm most that we talk about the most was actually one that we ultimately did not decide to pursue for a commercial product. Was we were working with the New Orleans Police Department and building this and using our Floodplain technology to build a stability score of police vehicles, actually deploying software inside the MDTs are called the mobile dispatch terminals, the little laptops that police officers have in their cars. We could install software on there and actually stream data off of the onboard diagnostic sensor in a car, which, as I'm sure modern vehicles are really just like big computers with wheels on them. So produce a tremendous amount of data any given car. we could stream that data in and build an internal stability score for a vehicle, and then actually aggregate that up and build it, say, for an entire unit or for an entire department if we wanted to. And we learned a lot from that. Ultimately, we decided that we didn't want to pursue the kind of vehicle as a business proposition. But as we turned our attention, with this technology to the industrial space, we found two things to be true. One was that folks in the manufacturing world were really interested, and I would say certainly aspired to be able to do real time learning from the streams of data that were coming off of their platforms. Unfortunately, the other thing that we learned is that the barriers to entry to that industry, so just from a technical perspective, actually deploying software inside of a manufacturing facility is quite challenging, and very challenging, in fact, if you're an early stage startup, without a deep track record and without a systems integrator walking in the door. So we found it quite challenging to actually get even an early pilot started where we were building even a custom tool on top of our floodplain technology for the customers that we wanted to work with. But one of the things that we learned from our customers through this process is that they were actually still really interested in using the technology, but using it not in a real-time way, but in what we came to call kind of a just-in-time way. So rather than having it stream the data off the platform, if they could just sort of periodically put data, yesterday's data or last month's data into a tool that uses technology to generate stability scores, then they could leverage that to either do their investigation or do their resource allocation. And so we ended up hearing this enough from the folks that we were working with at the time that basically back in 2016, the early part of 2017, I said, you know what? I don't want to build these kind of proof of concepts forever. I think this is a product that we can just go ahead and build. And so that idea ultimately became Alluvium Primer, which is our kind of flagship product built on top of our floodplain technology and designed not for the real-time use case, but for that just-in-time use case where customers can put data in, either individual data sets where they're doing forensic analysis, or daily data sets from the same facility, all captured for long period analysis, and get that stability analysis and leverage it to be able to do this discovery and reasoning about data.
So what is the architecture? I guess so you're not taking stuff off the PLCs. Are you getting it from the MES or the ERP, or is it more of a manual upload? And
the answer is sort of yes, right? So we right now, Primer is a cloud-hosted SaaS product. So data goes into it, kind of drag and drop from however a customer is able to export that data. Typically, a customer is either working off of a traditional historian platform, and there's many different vendors for those, or perhaps they have more of a more contemporary kind of data lake infrastructure where they're collecting data in a large cloud infrastructure, and then exporting that data into Primer. We will have a more integrated version of Primer coming out later in the year. But as it exists today, customers can drop in any data set that they have from their production systems. That data will get analyzed by Primer, and then this sort of it sort of operates as a kind of top level analytical tool where customers can then explore that data within the tool.
so one of the big issues that is facing manufacturing and also a lot of other sectors is, the fact that there's kind of a proliferation of protocols and systems from different vendors may kind of tag data with different metadata. Is there some customized work for you to go in when you deploy one of these and to say, we're using this set of equipment and this data means this, it comes from this system and so forth, and to kind of train the system a bit? Or is it really able just to kind of take in any data source without any, let's say, education behind it and make some sense out of these different disparate data sources and how they're interacting with each other?
Right. That's a great question, and really one that I think for us is part of how we think about this problem differently. So again, in the early part of our development, one of the things that I really was keen to focus on was not requiring our customers to have a big upfront cost in terms of the training of a particular model. Right, a kind of traditional way you think about doing machine learning is in this kind of supervised context. So, okay, I'm a manufacturer, and maybe I'm a particularly sophisticated one, and so I've already made a big investment in technology, and I've I've stored a bunch of historical data, and I can actually point to different examples of how particular assets fail. And then, I can hand that over to a vendor, and a vendor can build a model based on that. And then I can put that model into practice and then hope that now I'm able to prevent these types of failures in the future because I have some ability of identifying them. And there's absolutely nothing wrong with that approach. In fact, it's a typical way that you would even think about solving this. But we were really focused on having a different way of thinking about it because we felt there were two problems with that. One sort of obvious statistical problem is that in practice, you know, industrial operators are actually quite good at preventing catastrophic failures of their assets, right? They've been doing this a really long time. They kind of understand, even if it's just a general heuristic or set of kind of decision trees and best practices, if an asset starts to look like this, then we probably need to service it. And they also have, regular inspection, so they're predicting a lot of these things. When things do go sideways, it's typically kind of uncommon or rare events. And so just from a kind of basic statistical mindset, you would not want to build a model off of examples of failures that are themselves rare, right? We would call this kind of selecting on the dependent variable, which is the thing we wouldn't want to do. We wouldn't want to build a model of rare events and then put that in practice and only be able to detect things that don't happen very often, but actually be completely blind to a new scenario that we've never seen before, which is how these things typically go, and then that model not be a success. The other thing that we wanted to not have to worry about is only working with customers who had gone through the exercise of collecting data and storing it. Again, most of the customers in the industrial space are quite technically sophisticated, but may only be at the beginning of their kind of digital transformation journey. And so maybe they haven't already put a bunch of resources into collecting this data. So when we built Floodplain, we said we want to build a system that can do this kind of analysis from heterogeneous streams in an unsupervised way. We allowed the system to learn from the data on its own, and we have put a tremendous amount of effort into building an underlying kind of algorithmic approach that is both general but learns quickly. But as we say to our customers, our system starts learning from them on day one. It comes in as with a really powerful set of tools to understand data, but without that human operator interaction, it never gets any smarter, right? So we want to move our system and kind of move the paradigm of how our system works from a fully unsupervised approach on the first data set that goes in, but with every subsequent data set and with every subsequent interaction of the user, it's actually learning from that and moving to a kind of semi-supervised approach, right? We want every interaction, as I said before, to be that high value for the customer, but also be super high value for the system. And so and to go slightly more technical, we don't necessarily talk to our customers about this because the context might not be there. But if you're an industrial engineer using Primer, you are effectively a data engineer too. And what I mean by that is, with every interaction of the system, you're actually helping the underlying algorithms do their feature selection and do hyperparameterization of the models. Because every time you evaluate an alert and provide feedback, the system looks at that and says, okay, this kind of this sort of unbounded search space of potential feature interactions and neural nets gets a little smaller because I know a little bit more about what's important and what may be not important to this particular use case, and we learn more about that. And so that's how we're able to do it. Again, so it's not that there's some magic under the hood that says, oh, we can learn from we can learn from any particular use case, and you can just give us data, and this machine will kind of automatically generate these magic findings. No, what it does is it takes that data, given the approach that we have, it distills that into that stability score and generates alerts. And when those alerts are high value, the operator says, takes the appropriate action, and the system learns from that. But when those alerts are not high value, either false positives or there may be some context missing for the algorithm that the operator has, it won't make that mistake again. And so we get this kind of positive feedback through that iteration.
It's very clear that your primary customers here are the operators. But what about the OEMs? My brother just wrapped up his PhD. He's working for Intel now, and he's one of those guys that's kind of in a lab managing a $10 million machine, and it's like running a little bit of magic, right? The machine's not working now. Why is it not working? Nobody knows. tinker around with it, try to get it up as quickly as possible because it costs you a lot of money per day. And obviously, Intel has they're collecting data on this. They have a huge stake in maintaining uptime and utilization for these machines. But then the machine manufacturer also has a stake in understanding how are our machines actually operating, why are they breaking down, and so forth. So they would also be very interested in this data and understanding what in what cases their equipment is suboptimal and how they can improve in product development or in manufacturing. Are you working at all, or do you see interest? I know this is obviously a challenge moving data between the operator and the OEM. I mean, this is a long-term kind of business challenge, not really a technical challenge. But have you come across this, either requests for OEMs or kind of situations where the data might actually be more valuable for the manufacturer as opposed to the operator?
Absolutely, and the OEMs in this space have they have both a tremendous amount of leverage as well as what we think is a lot of incentive to work with companies like us and kind of folks who are building specific applications for their data, because the OEMs, as you state, they're the ones building the multi-million-dollar pieces of equipment, and they're out there trying to sell these more sophisticated assets that have more instrumentation on them, are generating more data. And from the customer perspective, so now you're buying that multi-million-dollar asset, you say to yourself, well, okay, it's this much more sophisticated, it generates all this data, but what am I going to do with that? And how are you as the OEM, how are you going to help me understand that data? Because I'm a manufacturer, I'm a refiner, this is not my core competency. What do I do? And so what we have seen is there are different kinds of OEMs who I think are taking a different approach here, but all of them are kind of staking out kind of real estate within the industry to say, we want to be doing analytics, building software platforms and cloud platforms for our customers to be able to leverage this data. I would say on maybe the most high profile example of this is GE Digital with their Predix platform. GE, I think, has taken a really kind of vertically integrated approach to say, if you buy a turbine from GE, they can kind of take you from deployment of that asset to data generation to an entire ecosystem of applications and tools that they can provide to the customer as an add-on to the purchase of that equipment. Right? I think part of it is both how the technology has progressed and how software has become much more of a central part of these OEMs' business, but also as an evolution of their business model. These high capex businesses, if you're selling a multi-million-dollar piece of equipment, you're probably only selling one or two of those to a customer every few years, and that's been a great business for those companies for a while. But having the kind of recurring revenue model that you get from a software services agreement is also a lot more attractive, right? It costs a lot less to do, and if you already have significant kind of structural advantage in terms of how your customers interact with you, well, that seems like a really smart thing to do. And GE is a good example of this. But Siemens has their own, I think it's called MindSphere. That's their cloud analytics platform. Honeywell likewise has their Sentience platform. Hitachi, all these companies have these big cloud platforms. And so for us as a startup, we're never going to never say never, but certainly we for the foreseeable future, there'll always be a tremendous amount of asymmetry between us and any one of these large multinational OEMs. The advantage that we have is that we are not locked into a particular asset line or OEM specification. So for a customer that says, listen, we have a mixed fleet, maybe we have a GE turbine and Honeywell process control, and we're also working with some Siemens SIs, we can come in and say, listen, all of that data is perfectly compatible with our system. And in fact, it's really, our system is designed to be able to take in all these different inputs and give you a top level view of how all of these things are operating together. And so we've begun to have conversations with some of these OEMs. I think there's lots of opportunity for us to work with them and provide, whether it's Illuvium Primer or a different application to exist inside their ecosystem. But it's still early days. And quite frankly, I think a lot of these large OEMs are still trying to figure out, what approach works best for them. Is it the kind of fully vertically integrated approach that GE has taken? or perhaps more of a community-based one where an OEM will say, listen, we can build a cloud infrastructure and we can get all the data to a central place, but we're not software designers and developers. We don't have that as a core competency. So let's go out and try to partner with companies like Illuvium or other ones. And so, obviously we've been more attracted to companies that are taking that latter approach.
Yeah, I think even GE, after sinking X billion dollars into Predix, are now looking more carefully at this community-driven approach and maybe deciding that they do need to be a bit more open. Actually, I know they're taking some pretty concrete steps towards trying to engage, with companies like Illuvium and trying to at least look at you. I would say not so much as a competitor, but as a potential, solution partner. Are you working? Your path to market. Are you working with these guys? Would you see GE as a potential deployment partner, or do you consider them, at least in the status quo today, to be more of a competitor?
Well, to answer the first question, we don't work directly with GE, although me personally, and we as an organization have a great relationship with GE Digital. Actually, was last fall I had the opportunity to keynote at the industrial machine learning workshop that GE hosted out in San Francisco, and I know the team there, and they do some fantastic work. And we just haven't found the right project to work on together yet. And not just GE, as I mentioned, the other OEMs out there, we're building relationships with them. These organizations are large, and you have to be able to navigate them. But me personally, I don't see them as competitors at all. In some sense, it's almost foolish to think of them as competitors, just given the asymmetry there, right? If these organizations, they don't really need to compete with a company like ours, because we don't do the same thing at all. We operate in the same marketplace, and we have sort of spiritual alignment in terms of how we want to serve our customers. But Illuvium is never going to build a turbine. We'll never ever be able to do that. In the same way that I don't expect large OEMs to be able to think about building kind of deeply technical deep learning models and real-time software infrastructure in the way that that I can, and the team that we have at Illuvium has thought about doing. So in some sense, it's much more of a natural complementary relationship. Not every company out there kind of approaches it that way. But my perspective is for those OEMs that are in the marketplace thinking about working with companies that complement their approach, that makes total sense to me. And I actually think that's true kind of across the board, even outside of the OEMs, because you have other systems integrators and infrastructure providers who themselves are not particularly well suited to build applications, and maybe looking for companies like ours to come in and provide specific solutions to specific problems that their customers already have.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ, and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.